Hi, this is Richard C. I'm a math tutor here at Wyzant, answering questions submitted by a student. This is from a topic called linear programming, which you typically would see in Algebra 2. The first thing you're going to do is draw a graph and put these inequalities in there. And doing that by hand is not too bad, but not that difficult, but time consuming. And I'm just going to save some time by showing you the graph that I did in Desmos. I think if you're not already familiar with Desmos, you should become familiar with it. It's very, very powerful, very useful tool. Okay, so let's get the Desmos graph out here. So these are the inequalities. There's a green and a brown and a purple. And they're represented by each of these lines. This brown line, this, I don't know what to call that. I called that purple, I guess, and green. And you can see that the intersection of these three constraints forms a triangular region. And this region in the middle, this is called the solution region. And it turns out that the optimization equation, the optimization equation will occur, the optimization will occur at the points of intersection. So what we do is very simple. We just make a list of the points of intersection. Here's X and Y. So let's start with this point up here, which is 0, 0. This point here is 3, negative 1. And then this point over here is negative 4, negative 4. And we're just going to calculate the value of Z, which is going to be negative X plus 5Y. So for 0, 0, it's going to be 0 plus 0 equals 0. For 3, negative 1, it's going to be negative 3 minus 5, which would be equal to negative 8. And for negative 4, it's going to be 4 minus 20, which would be negative 16. So here are the values for what the teacher is calling optimization equation. This is called usually the objective function. And the objective function is reaches a minimum or a maximum only at these points of intersection. So the maximum value of Z is going to be 0, and the smallest value of Z is going to be negative 16. So, for example, if you wanted to minimize the cost of producing items, then you would choose these values, negative 4, negative 4, to find the lowest cost way of producing these two products, product X and product Y. This has a lot of practical applications, and it's very useful. You're going to see a little bit of linear programming in Algebra 2, and if you go on to study math in college, you would see a lot more of it. It's used quite a bit in a wide variety of industries. Anyway, so that's it for this. This is just linear programming, and it's from Algebra 2 material. Okay, I hope this was helpful to you, and I'll see you again next time. Bye-bye.